Let's do some rapid fire hypothesis testing. Go to page 392, question 38, and this is what we'll be looking at with this data right here. And the question tells us an Alabama politician claims, keyword claims, can't highlight the word claims enough, claims that the mean annual salary for engineering managers in Alabama is more than the national mean, $100,800. The annual salaries for a random sample of 34 engineering managers in Alabama are listed. At alpha equals 0.03, or the 3% significance level, is there enough evidence to support the politician's claim? The first step is to set up our ho and our ha, our null hypothesis and our alternative hypothesis. And we need to choose which one the claim will be, but we have some hints from the passage. It says that it asks us actually, is there enough evidence to support the politician's claim? Now, since it's asking us to either give enough evidence to support or not give enough evidence to support, if you go to page 372, there's a table that has the wording we should use whether our claim is the ho or the ha, and notice that under the claim is ha column, that matches the wording that it's giving us. So that means that our claim would be the alternate hypothesis, or the ha. So we need to express this in mathematical form and verbal form to really have it make sense to us. Conveniently, there happens to be this table that has all this information ready. Wow, that's amazing. Let's look at our alternate hypothesis first, as it is our claim. The mean annual salary for all Alabama engineering managers is greater than $100,800. So mathematically, that would be as mu is greater than $100,800. Now our ho would be the complement. So given after examining the ho or ha for our claim, we'd go to the other and we'd make its complement. In this case, it's going to be ho, and the complement is going to be the mean is the mu is less than or equal to $100,800. So after identifying our ho and ha, what we're going to do next is specify the level of significance alpha, and we already have it in the question. It's going to be 0.03. And now notice it's going to be a right-tailed test, as in our alternate hypothesis, mu is greater than $100,800. So that means it's going to be a right-tailed test. Next, we look at what distribution we will make. Since the sample size is greater than or equal to 30, the sampling distribution of sample means is going to be normally distributed. After this, what we want to do is calculate the z-test statistic, and we want to calculate the p-value of it. So go to Geogebra. I'll go ahead and reload it here so you can see. Go to probability, once it loads, of course, and it will bring you to the distribution tab, but we want to go to the statistics tab. Go to z-test of a mean, which should be by default selected, and then type in our information. Our null hypothesis is $100,800. Alternate hypothesis is that the mu is greater than $100,800. And for a sample, this is where we would take our information right here, calculate the sample mean and the sample standard deviation. Lucky for us, that happens to already be calculated. 94,000, oops, wrong tab. $94,891.47, and our sample our standard deviation of our sample is, we're assuming, is close to the standard deviation of our population, since the sample size is greater than 30. This is from the previous chapter. And our sample size is 34. this will return to us that our test statistic is about -6.5, and our probability is going to be 1. Now notice it's not going to be exactly 1. The only way it could be exactly 1 is if we had the probability of the entire distribution. So even though it says 1, keep in mind it's just very, very close. So we look at our p-value and we say, hey, is this greater than or less than our significance level? Since our p-value is indeed greater than our significance level here, what we do is we fail to reject the null hypothesis. Let's write that down. Let's bold it. Fail to reject null hypothesis. So since we failed to reject the null hypothesis, if we go to the table on page 372, a convention to return to our employers about their claim if it is the alternate hypothesis and we fail to reject the null hypothesis, we will indeed say there is not enough evidence to support the claim. So in words, let's go ahead and write that. We'd say there is not enough evidence to support the claim that the mean annual salary for all Alabama engineering managers is greater than $100,800. And this is what we'd write down and return to our employers or for the question at hand. Once we complete problems like these, what we do is we look at our information and use our intuition to confirm, just kind of as a double check. So let's look at our sample mean actually. Our sample mean is $94,000 or about $95,000, but he's saying that the sample mean or the mean of the population is $100,000. So would the sample mean likely be $95,000 if the population mean is $100,000? I wouldn't think so, given our sample standard deviation right here, because the sampling distribution of sample means, or a standard error, is going to be way smaller than that. If you actually look at it right here, it's only 900. So this is -6 standard deviations away from the mean, assuming that $100,800 is indeed the mean of the sample means or the mean of the population. So it's definitely not. It definitely is not greater than $100,800 since it fell so far below $100,800. And that's a good way to check to make sure, hey, is this information accurate? All right, in the next problem, we will be doing the same thing, but with a small sample.